February 28th, 2017. 9:37 in the morning, Pacific Time, inside an Amazon data center in Northern Virginia, an engineer is doing something completely routine. The billing system for one of Amazon's storage services is running slow, and the fix is mundane. Just pull a handful of servers offline so the team can investigate. There's a playbook for this. He's done it before. He types the command, and one of the numbers is wrong. He doesn't know it yet, but he has just started a 4-hour chain reaction. Within minutes, Slack stops loading messages. Trello boards go blank. Quora throws errors. People reach for their phones to switch off a smart light or check a camera, and nothing responds. And then comes the part nobody can quite believe. Amazon's own status page. The dashboard that's supposed to tell the world what's broken can't load either. Because it was running on the exact system that just went down. No hacker, no storm, no hardware failure. One wrong value in one command took a huge slice of the internet offline. This is how that happens and why it can happen again. To understand the damage, you have to understand what S3 actually is. S3 stands for Simple Storage Service, and it's where the internet keeps its stuff. Photos, videos, app data, website files, backups, even the little icons on a web page. When you upload a profile picture or stream a file, there's a good chance it's living in S3. Thousands of companies don't build their own storage. They just rent space here. That's the whole pitch of the cloud. Let Amazon handle the hard part. But S3 isn't a single hard drive in a single building. It's an enormous distributed system spread across many thousands of servers and broken into specialized subsystems that each do one job. Two of them matter for our story. The first is the index subsystem. Think of it as the card catalog for every object in the region. It knows where every single file physically lives. Every time you read a file, write a file, list your files, or delete one, you're asking the index where to go. Without it, S3 still has all the data, but no idea where anything is. The second is the placement subsystem. When you upload something new, placement decides which servers will hold it. And here's the key detail. Placement can't work unless the index is already working. It depends on it. And one more piece. All of this was happening in a region Amazon calls US East 1 or Northern Virginia. It's the oldest AWS region, the biggest, and the default. So much of the internet and a lot of Amazon's own internal services pointed here by default. Hold that thought for a moment. So, back to that command. The engineer meant to remove a small number of servers from the billing subsystem. Because of the bad input, the command removed a far larger set, and those extra servers were holding up the index and placement subsystems. Now S3 is designed to lose servers. Hardware fails all the time. Removing and replacing capacity is a normal, everyday operation, and the system is built to shrug it off. But this wasn't a few servers. So much capacity disappeared at once that both subsystems dropped below the level they needed to function, and the only way to bring them back was a full restart. And while they restarted, S3 could not answer requests. No reads, no writes, no lists. The card catalog was being rebuilt, and until it finished, nobody could find anything. Here's the twist that turned a mistake into a 4-hour outage. These subsystems had not been fully restarted in years. S3 had grown so massively in that time that simply booting them back up and running the safety checks to confirm all that metadata was still correct took far longer than anyone expected. The mistake happened in seconds. The recovery took hours, and the failure spread outward. Other Amazon services that depended on S3 too to launch new servers, restore backups, or run code began to fail or slow down. Then thousands of outside companies that stored their data here went dark with it. Slack, Trello, Quora, Medium, smart home platforms, all of them, in a sense, were just front doors to data sitting in S3. But the most telling failure was Amazon's own. The service health dashboard, the page customers check to see if AWS is up, couldn't update because the tools behind it also depended on S3. For nearly 2 hours, the company couldn't officially tell anyone that S3 was down because the announcement system was down too. They ended up posting updates on Twitter. Quick pause before we get into the fixes. If you're the kind of person who wants to understand why these systems break, not just that they broke, that's the whole job of this channel every Tuesday. Hitting subscribe is the easiest way to catch the next one. Okay, the lessons. So what do engineers actually take away from this? Because an engineer made a typo is the laziest possible lesson. The real lessons are about the system around the human. Lesson 1, blast radius. The deepest problem here wasn't the wrong number. It was that a single routine command was even capable of removing that much capacity. A healthy system assumes humans will fumble inputs, and it puts guardrails in the way. After this, Amazon changed the tool so capacity gets removed slowly and added a hard floor. The system now refuses to drop any subsystem below the minimum it needs to stay alive. The fix wasn't, be more careful. It was, make the dangerous action impossible. Lesson 2. Hidden dependencies. A status dashboard that depended on the very thing it was monitoring is almost funny, but it's a perfect example of a dependency nobody had mapped. When everything works, you never notice that A secretly needs B. You find out the hard way, at the worst possible moment. Afterward, Amazon moved that dashboard to run across multiple regions, so it no longer relies on the system it reports on. Lesson 3, and this is the subtle one. The cold start problem. A system you never restart is a system whose restart you have never actually tested. Amazon assumed they could remove and replace capacity quickly because they always had at a smaller scale. They'd quietly outgrown their own recovery plan without realizing it. The answer is to break giant systems into small, independent chunks. Amazon calls them cells, so you can rehearse recovery on a small piece and shrink the blast radius of any single failure. And underneath all of it, Lesson 4, centralization. When one region becomes everyone's default, it stops being one option among many and becomes a single point of failure for the entire ecosystem. The resilient answer is to spread across regions and zones so that when one corner of the world goes dark, your service simply shifts to another. We call it the cloud, and the word does us a disservice. It sounds soft, weightless, everywhere at once, like it could never simply stop. But the cloud is just computers. A relatively small number of very large buildings, full of servers, run by a handful of companies, and an enormous amount of it still funnels through one region in Northern Virginia. The 2017 outage wasn't a freak accident. It was a preview. That same region has stumbled again since for different reasons, and each time the pattern is the same. A piece of invisible infrastructure we'd all quietly come to depend on, failing all at once and taking a slice of modern life with it. And it's creeping closer to home. The lights you control from your phone, the thermostat, the doorbell camera, the lock, and increasingly more of your house only works if some distant data center is awake and answering. The convenience is real. So is the dependency. Anything that relies entirely on one invisible system inherits that system's fragility. You can't fix Amazon's data center, but you can ask one question about the systems in your own life. What happens when this goes down? For the things that matter, your ability to communicate, to stay warm, to know what's going on, the answer should never be, I just have to wait and hope the cloud comes back. That's the whole reason this channel exists. Every system we depend on was engineered by brilliant people, but every system can fail. Understanding how is the first step to being ready when it does. I make a new one of these every Tuesday. If you want to keep pulling back the curtain on the systems running your world, subscribe, and I'll see you in the next one.